The U.S. Department of Energy is on the verge of achieving a cleanup commitment that has been decades in the making, treating Hanford's tank waste through the Direct Feed Low Activity Waste Program. Tank waste treatment is a key component of DOE's strategic cleanup vision. Direct feed means Hanford's waste will be separated at a tank farm to remove the more radioactive portion, so the resulting low-activity waste can be fed directly to the Waste Treatment and Immobilization Plant's low-activity waste facility for immobilization in glass. The first step of transforming the waste into a form safe for storage is to move it out of the tanks and transfer it to the Waste Treatment and Immobilization Plant just under a mile away. Tank AP-107 is where the tank waste treatment mission begins. Waste will be fed through a special system called the Tank Side Cesium Removal System, or TSCR. TSCR is comprised of three primary structures: the control room enclosure, where operators will control the process; the ancillary system enclosure, which houses an air compressor, electrical infrastructure, and other support systems; and the process enclosure that holds 3 ion exchange columns and a filter to treat tank waste. The TSCR unit uses filters to remove solids from the tank waste and ion exchange columns to remove radioactive cesium. TSCR is designed to process up to 7,200 gallons of waste per day, or 5 gallons per minute. The filtered out cesium and solids will stay in self-shielding stainless steel columns, each weighing about 30,000 pounds. When a column is full, it will be bolted to a nearby concrete pad for storage. The pretreated waste will be fed into another tank. This one is called Tank AP-106, and then transferred in batches to the Waste Treatment and Immobilization Plant. A robust double-walled pipe called a transfer line will carry the pretreated waste about 3,000 feet from AP-106 to the low-activity waste facility for vitrification. Once the waste arrives in the low-activity waste facility, a sample is sent to the nearby analytical laboratory, where chemists at the lab characterize waste samples and determine the appropriate recipe for vitrification, mixing the radioactive waste with 13 different glass-forming materials such as silica. The tank waste's complexity and differences in each batch require individual analysis to ensure the proper recipe is used. This step ensures the final product meets state requirements for safe storage. Tank farm waste is received in a special vessel inside the low-activity waste facility. The waste is mixed with glass-forming materials and fed to one of 2 giant melters. Inside the melter, the mixture is heated to 2,100 degrees Fahrenheit. As the mixture heats, 18 bubblers pump air into the liquid pool to ensure thorough mixing. Bubblers also contain temperature sensors used to monitor the temperature of the glass pool. The molten material will be poured into stainless steel containers and left to cool and solidify into a glass form. The containers will then be swabbed by a robotic arm to check for any contamination before being moved to the integrated disposal facility at Hanford. The low-activity waste facility will produce about 1,100 containers of vitrified waste each year. At the integrated disposal facility, the containers will be buried in engineered trenches called cells that will protect the groundwater and surrounding area from any contamination. Through treating low-activity waste, the DFLAW program accelerates the removal of waste from older tanks by creating space in safer double-shell tanks. The waste, now impervious and stabilized, will be safely stored to protect human health and the environment for hundreds of years.